Alright, this is the third video involving piecewise functions. This is actually a discussion of a particular type of piecewise function called a step function. And it's very inventively named, as I noted at the top here, because steps are essentially a bunch of horizontal lines placed next to each other so that you can climb a staircase. And that's basically what a step function is. It's going to be a bunch of horizontal lines placed on a graph that will look like steps going up. So now, or down for that matter. Now what we want to do is determine how do we place a step function. Notice again we've got a formula just like a piecewise function. Over here at the left, note the commas in here. So essentially each one of these, such as this piece right here, is just saying that f of x will be equal to 1 given its constraint. So our constraints again are over here on the right. Well, if f of x equals 1, basically that's a y equals 1 or horizontal line function. So what we can do is go back and just take a look and see that we basically have 5 pieces, all of which are horizontal lines. One will be a horizontal line at 1, or the second one is at 2, and then 3, and then 4, and then 5. So now we just need to figure out where do I start and stop. So for that first piecewise function, my horizontal line up where y equals 1 is just going to start at x equals 0 and basically go from x is less than 0 or go to the left. So if I'm going to go up to 1 or over to 1 in the y direction, but start at x equals 0, and again it's a solid dot because of the or equal sign, and I'm only going to travel directly to the left. Or basically, I'm going to start with a solid dot right there and travel directly out to the left. The same thing goes for the second piece. Now f of x equals 2. So I'm going to be up at y equals 2. So a horizontal line right up here at y equals 2. But traveling from 0, and notice no equal sign. So at x equals 0 up at 2, I'm thinking open circle. And then I'm going to travel directly over to x equals 2. So over at x equals 2, I'm again at y equals 2, and this time with a solid circle. When x is equal to 2, f of x equals 2, or f of 2 is 2. You can note that down here if we'd like to. So that's going to be a solid circle right there. And again, connect those two with a nice straight line, or as we've done right there. And then the next points follow that same idea. Notice very similarly, not equal to 2, but x is going to start at 2, so over here at 2, and it's going to travel up to 4. So between those two spots, I'm going to have my y values, my f of x values, equal to 3. Or essentially, from 2 to 4, we're on a horizontal line up at 3. And again, notice, no equal sign on the left, a positive or an equal sign on the right, so open circle to closed circle, left to right. Same idea for the next one, again from 4 to 6. So again, we'll go out to where x is 6, and we're going to have a horizontal line up at 4. So that same idea there. And you can see where it starts to form those steps going up and to the right. Now you'll notice the last section is a little bit wider. It's going from 6 all the way up to 10. So it's going to travel from 6 to 10, but again be up at 5. Again, open circle on the left, closed circle on the right, and there you go. And after 10, notice that x, and for 11 or 12 or even anything slightly greater than 10, doesn't fall anywhere in our grid. But for everywhere from 10 and down, from this solid circle all the way down following our steps, if we would pass a vertical line test, we never run into two solid included circles anywhere in our line, so this still does qualify as a function. It passes that vertical line test. Every input has exactly one output. That's a step function. I hope that helps you understanding again one more type of piecewise function, and on to part number 4.